Okay, next up we have Matt Johnson. And Matt is the Canada Research Professor in Energy and Combustion-Generated Pollutant Emissions at Carleton, and an adjunct professor at Western University, specializing in experimental research relating to pollutant emissions in the upstream energy industry. He completed his PhD at the U of A in 2001 and went on to work as an NSERC postdoc fellow at Lawrence Berkeley. He was appointed as the Canada Research Chair at Carleton University in 2006, and he's the author of numerous journal articles and is frequently invited as a lecturer nationally and internationally. Professor Johnson and his team have developed the optical technology for measuring black carbon in plumes and novel approaches for detecting and quantifying fugitive emission sources and performing techno-economic analysis of GHG mitigation potential through flaring and venting mitigation. His Energy and Emissions Research Lab collaborates closely with government and industry, drawing support from a variety of national and international organizations, including NRCan, the World Bank, United Nations Climate and Clean Air Coalition, PTAC, ECCC, and NSERC. Please welcome Matt Johnson. I'll turn it over to you, Matt. Thanks.
Thank you, Larry. Hopefully you can hear me okay. You see the slides okay. So thank you for this opportunity, and thanks for people who are tuning in. Really appreciate that. And what I thought I'd do, per Larry's instructions, is just try to give an overview, not too long, about the range of work that we're doing in our Energy and Emissions Research Lab, the kind of facilities we're using, and maybe we'll see what that leads to down the road. So as Larry mentioned in the kind introduction, we are the Energy and Emissions Research Lab. We're based out of Carleton University in Ottawa. And our mission is targeted research focused on the upstream energy sector. So within that context, we have multiple facets to the work we do: quantification and mitigation of pollutant emissions, controlled labs experiments, but backed very much so by full-scale field measurements. Quite a bit of work on novel optical diagnostics and developing measurement tools. This is model development, inventory analysis, techno-economic analysis, and ultimately, all this is geared towards useful outcomes: policy, regulatory support, and enabling mitigation actions. And so a core strength is we're lucky to have a number of national and international partnerships, and as I'll hopefully show, we're leveraging what are fairly unique globally experimental capabilities and facilities. And so of course the strength is our team. Currently we're 14 highly qualified personnel, and that's a mix of PhD research engineers, graduate students at both master's and PhD level, and support staff, who are, I'm just so privileged to work with these people, and yeah, keeps you young, that's for sure. That team is working in a number of facilities that are, I think, relevant in the CanERIC context. First is the Carleton University flare facility, and what makes this unique in particular is the capability of handling multi-component fuel species, so C1 to C7 species, so into the liquid components. And so a lot of technologies, that's an important thing to test, especially for flares and flare emissions, but beyond that, if you're trying to get optical diagnostics that can work with real-world gas compositions, comprehensive suites of combustion diagnostics for gas and aerosol species, laser diagnostics and imaging. And of course, as you can see in the pictures, what is a kind of entertaining large-scale open flame. As I used to tell my kids when they were little, what do I do at work? I light big fires and shoot them with lasers. It's what could go wrong? Beyond that, we actually are fortunate to have an optical technologies lab also at Carleton, and here we're focused on customizing. There's some development to be sure, but customizing optical diagnostics so that we can deploy them in the field. And so notable technologies I'll talk about very briefly are Skylosa for black carbon, that's developed a few years ago in our lab and maturing nicely now, and then Aventex technology for methane flux measurements. We're hoping to bring forward in trials through CanERIC at some point in the future. And so there's other aspects to this beyond that, as you can kind of hint in the photos, potential drone deployments and kind of innovative uses of flare measurement sensors that we've deployed around the world. Basically a lot of fun and interesting capabilities to add to the mix. Third facility that we're using. As Larry mentioned, I'm actually fortunate to be an adjunct professor at Western University in London, Ontario. And so that is where we're running one of the key facilities in FlareNet, what is truly an internationally renowned facility here in Canada and one of the largest combustion capable wind tunnels in the world. And so the work that's going on here is primarily under FlareNet, and it's focused on methane slip from flares. As we talk about some of the outcomes of this and crediting opportunities and things that might appear in a tier program, these are the kind of data inputs we need to help enable those kind of crediting opportunities and mitigation actions. And then finally, I think what makes us a little bit unique is probably 50% of the time in our lab, we're not in the lab. We're deploying to different parts of Canada and then internationally around the world. At this point, we've done and continue to do, we've been out in the field in Canada just in the last couple of weeks, doing fairly extensive work in all three main production provinces in Western Canada, but also internationally, US, a lot of work in Ecuador, and then, good story over beer sometime, but we've been as far away as Uzbekistan doing measurements, if you can believe that. So changing gears from that overview, I thought I'd just highlight some of the major projects that we're currently working on, and then hopefully get to questions from there. So one key focus right now has been testing and deployment of novel airborne methane measurement technologies. And there's two in particular we've been working with. One's from Bridger Photonics and another complementary and quite different technology from Scientific Aviation. And so the work we're doing here is in a couple of fronts. First, we're trying to objectively, in a third-party, peer-reviewed kind of way, look at detection and sensitivity limits and quantification accuracy of these technologies. And then because we're doing large-scale survey work, we can use data analytics of that to update inventories, which has happened already, and inform policy. And then some of the more interesting things that are ongoing now, particularly in BC, is to compare with ground-based measurements. And that touches on alternate LDAR, but in particular on LDAR effectiveness, and then thinking just slightly to the future, maybe opportunities to streamline or improve regulations to make them more efficient. So part of that testing, just to elaborate a little bit, is we've been running blinded methane trace releases. So in this kind of work, the airplane doesn't know where we are, initially doesn't even know we're doing this. And so we're setting up wind sensors, chasing planes in a team of trucks, which is quite entertaining, and releasing methane and testing the ability of the plane to find it. And so this kind of work hasn't ever been done, to our knowledge, in this kind of truly blind way, and is key if we're going to start carrying these technologies forward. And a number of companies in Canada are looking to use these technologies as alternate LDAR approaches. Just to give you an idea of where that sort of analysis goes, is a couple of pictures here from tracer releases, some that are found, some that are missed, which is actually ideal if you're trying to learn something. If we bring in additional data that Bridger has, just to give you a preliminary idea, we're able to define sensitivity limits that turn out to be a function of wind speed. And so now when an airplane measurement happens, this is work that we're expanding, I should say. I'm just showing you what's where we are right now, current as of a couple of weeks ago. And when a measurement happens, you now have insight into what it was capable of detecting, what the lower limit was. And the gray dots here are actual field survey data for northern BC, and so it seems to respect that line quite tightly. And this is the kind of key quantity of insights that I think this isn't technically work under CanERIC, I should say, but it's very much within the goals of CanERIC to test, quantitative, objectively evaluate technologies, and then ultimately bring them forward if they're useful. So pivoting from there just a little bit, that takes us into data analytics, which we spend probably, I'll say 50% of their time. I'm pretty sure if I keep saying percentages, I'll add up to about 250% here in a second. But a particularly interesting thing has been combining aerial and ground survey data, trying to interpret what that means. And so two projects here I'll highlight. One is ongoing with BC Oil and Gas Research Innovation Society. And so we're using OGI camera data from a set of sites, comparing that with airborne measurements at the same set of sites, contrasting those, which is giving a number of interesting insights for how we might streamline regulations in the future. Slightly earlier than that, we collaborated closely with Clearstone Engineering, doing analytics on field component count leak survey data. This is work that was actually published about 2 years ago now and has been adopted into revised provincial and federal inventories. But that sort of analytic work is continuing on the inventory front. So there's another aspect of what we're doing in the lab. I mentioned in my quick overview optical diagnostics, so I thought I'd just touch briefly on 2 aspects there that we're working on. One is this SkyLosa technology that's been developed to measure black carbon emissions and plumes. And in many ways, it's not dissimilar to the technology Kyle's been talking about, although this is on particles, which is a much simpler problem, I will say. So this is a much more mature technology. And this was initially brought forward as a PTAC project a number of years ago with NRCan and ECCC support, and later on World Bank, and now has been deployed in multiple countries. So it's a nice Canadian technology development and success story. And then on the earlier development phase, we're working on a technology that we're calling the Ventex for direct measurement of methane flux, and I'll talk a little bit about that in a second and how that might be brought forward in CanERIC. So, but first, for those of you who haven't seen this SkyLosa technology, hopefully the video comes through your internet connections, but what you're seeing here is the result of a field measurement and post-processing of data. The upper left image is more or less a black and white camera image as you would see it, and as that sooty plume crosses that red control surface, we're making a quantitative measurement, which is plotting in synchronized time on the graph below. And so you can see the consumer grade image I should have said on the right. That's more or less what I would see. The gray image is what the scientific camera sees after some interpretation. And at the end of the day, you're getting a quantitative measurement. The blue dots are the actual assigned value, and the gray bands are the uncertainty. And so, while this is for black carbon, it just kind of shows the technology development. And black carbon itself is a short-lived climate forcer. So although methane gets all the attention, there's lots of opportunity, especially internationally, with black carbon. Switching gears again, on the Ventex front, I've talked about this a little bit in CanERIC. This is a new technology being developed through NRCan's Clean Growth and Innovation Program. And essentially, we're crossing a pair of laser beams and looking at a very subtle Doppler shift as the methane flows through. And what's really neat about this, it's an elegantly simple concept, although believe me, it's incredibly complex to get to work. What we get is a direct optical measurement of methane flux. Most technologies that you see will either measure concentration or velocity and make some combination. SkyLosa is an example along that line. This is uniquely measuring the flux directly, which is quite neat. So where are we with this technology? This is actually originally developed. We started work on this, trying to develop a technology to measure VOC emissions from storage tanks. And so we have an early prototype, not geared toward methane, I should say, that's been installed in Devon, Alberta, and has survived 3 winters, still outputting data. And so this is the genesis for this Ventex idea. And now what we've done is we've pivoted. Here's the rendering of the device now. It's actually undergoing some further refinements, but essentially it's an optical head that can connect to key sources like storage tanks or casing gas vents, things that are traditionally very difficult to measure. And that's connected to a remote, at the moment, a remote base station that can sit in the back of the truck, is about 2 feet by 3 feet. And that allows it to deploy to hazardous areas. We have been talking about field testing through CanERIC. I think there was originally a project proposal for this summer. It looks like that's potentially delayed, but not something we're losing sight of at all. And so in the meantime, we're working on a refined version that packages a little more tightly together. But thinking of the overview of the Energy and Emissions Research Lab as a whole, that's on the optical diagnostic front. In the brief time I have left, I should touch on that we've done quite a bit of work on the techno-economic analysis of methane mitigation potential. This has resulted in a number of peer-reviewed publications, but really the goal here is, what are the opportunities for reduction? And that's a continually evolving question. How might we determine crediting opportunities? So among others who might be on this call, sitting on the committee trying to revise the solution gas conservation protocol for Alberta, which might open up methane reduction projects to the TIER program. So this type of analysis is a backbone in understanding how you might approach those sorts of things. So that's another aspect of the work we do in our lab. I should mention very briefly, and Kyle talked about this in his work, that out of Carleton University, we lead the NSERC FlareNet Strategic Research Network. So that's a collaboration with the University of Alberta, University of British Columbia, Western University, University of Waterloo, and National Research Council, and then backed by a number of government and industry partners. And so, although I don't have time to go into the activities of the network as a whole, it's a fairly large and comprehensive multi-year endeavor. And among key objectives is quantifying efficiencies of flares and methane emissions in turbulent crosswinds. Other aspects include optical technology development, which is what Kyle was presenting, that might lead to better flare efficiency measurements. And of course, we've been doing a lot of field work on the black carbon side. And so how does all this get used? So a number of fronts, from the lab-based work, field work, measurement technology development and deployment, analytics. Ultimately, we're trying to help improve inventories and drive mitigation. I think we all have the same goals. And so we're collaborating with federal and provincial governments to do just that. Some of these things are in peer-reviewed publications. Some of these are in reports submitted directly to government. Canada's reporting on black carbon is now based on a model we've developed for them just in the last 18 months. Among others, we've contributed to CSA technical committees, and I already mentioned hoping to help update the solution gas conservation protocol, which is absolutely a critical goal to enabling methane mitigation in Alberta. And so, as a whole, I think a key mission of any university-based lab is dissemination through peer-reviewed outputs, and so that's certainly something we take very seriously. Beyond that, that's as much as anything, that's the peer-reviewed backstop, but then we try to go beyond with our industry and government partners to try to make sure that we can help solve problems that matter. And so we're very lucky to have a number of close collaborators nationally, NSERC and NRCan especially, but ECCC, we've worked with AER, a number of university partners, Clearston Engineering, BC OGRIS. And then internationally, we've been doing a lot of work with the World Bank of lately. Collaborations that are active with the University of Utah, Petra Amazonas, Moscow State University, and I've previously done work with the EDF and others. And so we're very lucky to be plugged into this broader national, international network, and it makes it a lot of fun. So with that, hopefully that's a useful overview for you on the line, and I welcome any questions you might have.
Thanks, Matt. I think you were at 250%.